Good afternoon, everybody, and welcome, all of you. Nice to see so many here today. Today is Gro Birkefeldt Møller Pedersen's PhD defense. She has submitted a volume, a thesis, which has been evaluated by the committee, who I'll present in a moment. The PhD has been supervised by Per Nürnberg from the department here, and got to get the names right. Harald Palle Gunnlaugsson from the Department of Physics and Astronomy here. The evaluation committee consists of Mary Chapman, Dr. Mary Chapman, senior scientist based at the Planetary Science Institute in Tucson in Arizona, USA, and Dr. Dennis Weiss from the Planetological Institute in Westfalia Wilhelms Universität, Münster in Germany. And I'm the chairman of the evaluation committee, Richard Wilson. The procedure today is that Gro starts by giving a talk of about 45 minutes, presenting the main points of her thesis. We'll then have a break of about 10-15 minutes, and then the debate, discussion, defense will take place. Gro.
Thank you. Welcome everybody. It's nice to see such a diverse crowd here today. Before I start my talk entitled Geomorphological Study of the Galaxias region, Elysium volcanic province, I have a lot of people to thank. First of all, my supervisors, Fernanda and Palle, as we usually call him, from Aarhus University, for providing me this possibility to do some planetary studies. Extending my thanks to Jim Head and the Planetary Science Group from Brown University that I've been cooperating with a lot, and the Department of Planetary Sciences and Remote Sensing from the Free University. Moreover, I would like to say thanks to the committee here today. I'm really happy you could be here, Mary Chapman and Dennis Rice, and also thanks to Richard Wilson, of course. And then I would like to thank my family a lot, and all the nice students and PhD students I have shared my time with the last 4 years. So, the motivation for this study, or the initiation of this study, started because the Mars Simulation Laboratory at Aarhus University got access to some new remote sensing data because it joined the Mars Express simulation laboratories, and we decided to put up a project where we were exploiting this new access of data. So we ended up with a geomorphological study here in the Galaxias region. First of all, because a lot of new data has been retrieved the last 15 years with new satellites around Mars. And secondly, because this region right here is situated in between this volcanic province called the Elysium volcanic province and this basin called the Utopia Basin. And we thought a lot of nice activity could take place here, complex activity, and definitely that is what we saw in the end. So just a short agenda for today. I'll start out with an introduction of my study area, introducing the data as well and the mapping methodology. And then I have decided simply to focus on 3 types of landforms. Much more have been mapped, but these are the 3 landforms that where I have been able to publish papers so far. So I'll concentrate on periglacial landforms, dikes and dike swarms, which is kind of volcanic landforms, and then in the end on Galaxias chaos, which is a kind of landform which does not exist on Earth. And then finally, to sum up the mapping in general, some conclusions. So, what you see here is a topographic map of Mars. Over here, you can see the height around 21 kilometers is red. Dark blue is around -8 kilometers. And the study area is up here. You see in blue here, you have the northern lowlands, and in orange and red, you have the southern highlands, and then you have the biggest volcanic province, the Tharsis volcanoes, right there. And I decided on just to show you how things are related to make this Google tour for you. So here we have the study area. This is the volcanic province, Elysium. and Utopia Basin. And as we go around, you'll be able to see how the northern lowlands are connected up here. This is the southern highlands. Here we have some big outflow channels. I will come back to those in a minute. And here you see the biggest volcanic province on Mars. And as we continue, you can see that the Elysium volcanic province is situated within the northern lowlands as the biggest volcanic region. So, zooming in on the outflow channels here, called the Kreis outflow channels. There's a lot of chaotic regions called chaos formation here. You can see a huge river system draining out in the northern lowlands and some nice streamlined islands here. And what is important to note here is that what is draining out in the northern lowlands is actually connected all the way to my study area here, within the northern, within the basin here to the north. Just as a final, you'll have a look here. This is the study area I've concentrated on. So you can see the Elysium volcanic province here, Hecata's Tolus, and then Utopia Basin here. So back to the slides. Just to have a closer look. So this is the study area. Parts of Hecata's Tolus is included, some plateau of Elysium rise, and then you have parts of Utopia Planitia up here. And before starting this mapping project, we were trying to evaluate where can we have material transport from outside the study area, which is entering the study area, simply trying to constrain what could have impacted the area where the source region is from the outside. And generally, we will expect we have some lavas coming from the Elysium plateau here. We might have some material from these big outflow channels that have been draining out here in this basin. And we have also a significant part of material from the Hesperian outflow channels, the outflow channels that I just showed you before as we took the Google tour. So, my data is primarily coming from these 4 satellites: Mars Global Surveyor, Mars Odyssey, Mars Express, and Mars Reconnaissance Orbiter. And what is important here to note is that these different satellites provide you with different kinds of images. So you can have images of different resolution, which has different coverage of the planet. Up here at Mars Global Surveyor, you can see we have some images called map images with a resolution of 1.5 to 7 meters per pixel. And we also have some data called molar data, which is a topographic data set, DEM, with a resolution of 460 meters per pixel. Another interesting data set is what, the high-rise and CTX images from Mars Reconnaissance Orbiter, which high-rise in my study area has mostly a resolution of 0.5 meters per pixel. That will be 50 centimeters per pixel. In other areas, you have a resolution of data all the way down to 30 centimeters per pixel. And then we have CTX images that I have been using a lot. So basically, different kind of imagery and topographic models that can be used in this kind of study. So here is my study area again, the Galaxias region. And over here, it's the same area showing the footprints of the different kind of data. So what you see here as some small red and blue stripes here is the mock and high-res imagery with a really high resolution. But as you also can see, it has a fairly sporadic extent. Thus, it's not really good for regional mapping. This area here is similar to the size of Spain, just for giving you some kind of marker. However, CTX data here in the white footprints, the light gray is Themis imagery, and the black here is HRC, is some of the most important data sets that I have been using for this study. So, what are we trying to resolve when we're doing a geomorphological study? So this is basically a landscape from Earth, and what the geologist is going to do is trying to resolve the different kind of processes that have shaped the landscape. We have glaciations, we have river systems, we have marine areas, and we have volcanism and tectonics. So when people, geologists, go out in the field, they're trying to resolve this geologic history by looking at the stratigraphy, the mineralogy, the petrology, and all the different kind of things. However, this is a bit difficult when you only have satellite data. So the main things that we have been using for classifying and discriminating units is these 8 different characteristics. So when we were looking at the images, we were looking at the surface morphology, the geomorphometry, the albedo of the units, textural properties, relative age, thermophysical characteristics, and contact to neighboring units. Sadly, my region is a bit dusty, so the mineralogical information has not been used in this case. And then when we have been finding out that we have one unit which is significantly different from another unit, we try, so to speak, to walk the contact. So we are basically following the unit along and trying to map it out, just as you would do in the field when you have found a contact and you want to follow it. Furthermore, we try to apply some stratigraphic principles. Stratigraphic principles is widely used in geology. And the most important and powerful tools that I could use was cross-cutting relationships and hiatuses. Cross-cutting relationships is basically just where you have a unit which is cross-cutting another unit, we know that this unit is the younger one. So up here, here in red, you can probably not see that well, but basically the idea is we have 2 red units here, and then we have the white one. And the white one is superposing and cutting these 2 other units, and therefore this one must be younger than the 2 other ones. Hiatuses can be used because we can look at different kind of impact craters. This yellow thing here is a crater and an ejecta from an impact crater, and we can map out these kind of morphologies and get an idea of how old the surface is, simply because the older a surface is, the more impact craters would have hit the surface through time. So this is what the geomorphologic map looked like. I don't expect you to get a whole lot out of it, but here I have a detailed legend. This is the map itself. This is the footprints, as I showed you a bit earlier, and here we have a stratigraphic column. And here again, just to zoom in on the geomorphologic map, you'll see it quite some time during this talk. We have the red unit here is lavas and volcanic stuff. The blue stuff here is basin-related landforms. And as I already said, you have all the yellow stuff here is impact craters. Then we have some outflow channels here in the region. And I will come back to some of those landforms later on. So